An Eulerian trail or a path is a path which visits its vertices only once. This means that the trail can be drawn in a single stroke. In order to determine if a path or trail can be drawn in one line, we can look at how many lines intersect at each of the vertices.
This is Handsworth Math Club, as you know. Today we're going over Eulerian trail. We're going to learn what this actually means in a second, but first of all we're just going to draw a drawing. Like, let's say I challenge you guys to draw this drawing without actually releasing your pen from the paper. Starting now, you can use the board over here, okay? Like, I'll just give you about like 2 minutes, 3 minutes. Is that fine? Yep.
I think that's a good amount of time.
Okay, good amount of time. So did anyone get the answer? Of course not. Because it's impossible. Like, we've done this a lot of times and it's completely impossible, right? Well, the reason behind this thing is actually, it's pretty simple. You have a dot here, and we just draw all the dots over here. There are actually 4 dots in this little drawing, right? And guess what? If we count okay, my bad. This is actually possible. sorry. I was thinking of something else. Well, it's pretty simple. If we just let me just use another marker because we need a different color. If we start from here, we actually can do something like this, right? Wait. Yeah, this. Great. But I want you to try something much more complex this time. Sorry. It's a bit of... Wait, no, I'm not supposed to do that. Things like that. Let's say we do... yeah, let's try drawing this thing without releasing your pen from the paper.
No, stop.
The answer is simple. You literally can't do that, because if we just show all the dots in here, we see the dots that are connected that has 2 lines attached to it, like 2, which is even, and we see 3, which is odd, and so on and so on. Well, the reason why this is impossible is there is actually more than 2. Let's call these dots an odd dot. No offense. Whoops. So we see these odd dots over here, and wait, this is even. Odd. Wait, hell. I messed that up again. Hell. Yep. Odd. Odd. So as we can see here, we have 4 odd dots, and let's see. You know, I'll use this. And this shape we just drew had actually, wait, just a clarification. Had actually 2 odd dots. One over here, odd, odd, even. Right? So what makes this drawing possible, but this impossible to draw in one stroke? As we can see, we have 4 odd dots in here. 2, 3, 4, as I said before. And a drawing should start somewhere. Okay, so let's indicate this point as some kind of stations, right? We enter the station and then leave, right? So every dot should have an entrance and an exit line. So that makes the point an even dot, even point. Well, what if we just start from this dot and does not return to this dot? That makes this dot an odd dot. So what? Let's try drawing this shape starting from even dot. It's impossible. I know it because I'm genius. Well, anyway, you should always start from the odd dot and end in the odd dot to complete a one-stroke drawing. Just like, let's start from here. There. You started from an odd dot and then ended an odd dot. But this one has 4 odd dots, and we only need one entrance and one exit and nothing else, right? So that makes us start from odd dot and end on odd dot, but everything else should be even, right? Because we go in and go out of the dots. So we indicate this shape. Impossible. It's not possible. This type of one-stroke drawing is called actually Eulerian trail. So let's say, how about you guys just tell that this drawing is possible in Eulerian trail or not? This one, pretty simple, right? I just did that. You know, let's just come up with something more complex, such as. Yeah. Do you guys think this is possible? Possible with one stroke? I'm looking for answers. You think it's not possible? Well, if you look at this is an even dot because 1, 2, 3, 4 lines going inside the dot. And this one's also an even dot, even. And this one's also even. We go in and we go out. This one's also even. And then we have these 2 odd dots, which implicating the start point and the end point of the drawing. So if we just do this is technically, wait, I messed it up. Let me just, there we go. Yeah, it's possible to draw this thing in one stroke, right? Well, how about we come up with something with 4 odd dots, as I mentioned before. Well, this one. Will this thing be possible in Eulerian trail? Is this possible in one stroke? Okay, so is this possible or not? Is this possible in one stroke though? Yes? I think not. Well, there's actually 4 odd dots in this drawing, just like one in the left, right, down, right, down, left. Which makes us, for making the Eulerian trail possible, there should be only 2 or 0 odd dots in the drawing, as I mentioned before. This one has 4. It's technically not possible. Like, you enter from here, exit from here, enter from here, exit from here. Boom. You need at least 2 or 3 things to just complete this drawing, because it got 4 odd dots. Odd points, or whatever. Right? Since this, and, well then, let's ask about something different question. How many strokes will this drawing need to complete this? How many strokes? Anyone? Well, let me give you a hint. Each pair of odd dots represents an entrance and the exit, where the stroke starts and the stroke ends.
2?
Yes, 2. Finally. Since we've got 4 odd dots, these two is going to be exit and entrance, and these two are going to be exit and entrance. So it's possible, like this, and then this. Then two strokes. Well, how about we add something more complex, even more complex, such as that's not supposed to happen. Geometry. Well, how many strokes would this drawing need then? How many? Why don't we just count the odd dots first? That's the hint. Yes, 6 odd dots. And how many strokes?
3.
Yes, 3. 1, 2, 3. Because there's 6 odd dots, which means there's 3 pairs of odd points, which gives us 3 strokes. And well, this is getting pretty easy, right? How about I give you something really random, such as, you know, too random. Yeah, that's more like it. How about this? I have no idea. I just drew this from thin air. Okay. We'll see about that. Let me just label the points. How many strokes would this thing need to complete this? Well, how many? Just shout it out. I don't care. Please, just shout out the answer.
1, 2.
Okay, 1, 2. It's quite complex, but we start off by counting the odd points, right? 1, odd point. 2, second odd point. These are all even this one. So there's only 2 odd points, which gives us 1 pair of exit and entrance. So this one is actually completable by drawing 1 stroke. Let me just try that.
Wait, if you go like all the way around,
Sorry?
yeah.
Okay, let me just replicating the shape then. Get lost. Okay, here we go. Oh, wait, let me just try again. I'm not a really autistic person, so don't question me. Boom, only 1 stroke. That's all we need because there's only 1 entrance and 1 exit. We start from here and exit from here, or we start from here and then exit here. Doesn't matter. Okay, so why don't we just start in drawing some random things then? Well, I just want to add a line over here because why the hell not? How many strokes would this need then? I mean, it's simple.
Oh, 2.
Yeah, exactly, 2, because I just added 2 more odd points in here, like 3, 4. We just do the one thing and then draw another stroke there. Easy. But what if I just erase this thing and then add a stroke in here? How's that? Yeah. Okay. You know what? This is quite messy. How about we do this? How many odd points are there? How many odd points? Yes, 0. There's no exit or entrance. We can start from nowhere and end at that point. Because it's all even, right? Hell, we should just start from here and then draw the whole thing out. Do you guys want to see me try?
Yes.
Yeah. Let's just try. There. Start from the same point, end at the same point, because there's no odd points in there. Well, let's have one question here. Do you guys think it's possible to have 3 odd points in a drawing? Yes or no? Yes? Well, I'm telling you, it's impossible to have 3 odd points in a drawing. It's impossible because you have to start from one point and end at the other, right? You can't have like, how do I say this? Start at one point and then just end at 2 points. Like, that's ridiculous. So, let me just give you some problems to solve. Well, we got figure number 1 and figure number 2. Let's see if these two are actually possible. Let me just indicate the points here. Please just give it a try, okay? I'm not going to go over this thing right away. Like, that's ridiculous. Yep. We just need to find the odd points and the even points of these two shapes. Okay, actually, you know what? Try these things on your paper. Like, just give me how many minimum strokes it is needed to draw all these things, all these shapes. I'll just give you like 5 minutes. Well, if you got an answer, you can just come out and just solve the problem.
Oh, I didn't see that.
Okay, to make this thing sure I understand. Huh?
3 strokes for the first one.
3 strokes for the first one.
In the first one,
Or is it?
Please excuse this announcement.
Are you sure?
Any students that are
I don't
interested
know. I'm not
in
sure.
the UVic
Uh-huh.
Business School of
Well, it's wrong.
Excuse me.
It's wrong.
Gustafson Business School. You can go to room 1036 where there's an information session.
Try again.
Is it 4 strokes?
Yes, it's 4 strokes. Now prove it. Get the marker.
I don't know how to draw.
No. Just count these freaking odd numbers. I mean, odd points. That's all. That's all you gotta need. Come on.
I'm going on first, bro. Okay.
Okay, here's your green marker. You can just go find the points.
1,
Mm-hmm.
2, 3, 4, 5, 6.
Yes. And how many odd points are there?
8.
8, which gives us 4 pairs. And that's a 4 strokes. That's a 4 strokes. And this one's a lot more difficult. Try it, please. Come on.
2.
No, it's not 2.
But it's like, no, there's 4, 2.
Oh, I was just saying number 2, you know. Trust. These all.
Anyone got an answer?
There's 4 strokes, 4 odd points.
Nuh-uh.
What?
It's wrong. It's wrong.
There's
You're
4
wrong.
odd points.
It's not 4 points. I mean, it's not 4 strokes, whatever.
4 odd points.
You sure about that?
Oh, I'm not tripping. Pretty sure it's 4. Oh, that's what I just said.
Max said 6. Odd point.
Yes, Max, you're right. There's 6 points. This one, that one, this one, that one, this one, that one. There's a total of 6 odd points, which gives us a 3 strokes.
1 is an odd number, I forgot about that.
Yeah, 1 is actually an odd number. Yes.
You tricked us.
I didn't trick you. 1 is an odd number. It's obvious.
Yeah, Nagi told me it wasn't. I'm not gonna lie. Yeah. Yeah, he tried to get me.
Well, why don't we? Okay, there's plenty of time left. Like that's literally all of the Eulerian 12. Like it's all of them.
Can you do another
You
one?
guys want to do a short Kahoot?
Yeah, sure. That'd be nice.
Thank you.
Well, to be honest, I'm not sure if we can stream this.
June, can we have your outro?
What am I supposed to do an outro?